Principles of Technology, Unit 10, Part 4, Energy Converters in Electrical Systems.
Electrical energy converters are probably the most common because electricity is such a versatile form of energy. Electrical energy converters take electrical energy on the input side and convert it into either thermal, fluid, or mechanical energy on the output side. This includes electric motors, fans or pumps, and devices like electric heaters. Let's look closely at the electric motor. We have seen that when a current passes through a coil, a magnetic field is produced. An alternating current will cause the north and south poles of the field to rapidly exchange positions. If the coil is placed between two permanent magnets, its changing magnetic field interacts with the permanent magnets, causing the coil to spin. Electrical energy has now been converted into rotational mechanical energy. Reversing the process, that is, turning the coil mechanically, produces electricity, and you now have a generator. To find the efficiency of an electrical energy converter, the energy out is compared to the energy that was put in. Electrical energy in is usually measured in joules. If the output energy is mechanical, it can be measured in foot-pounds of torque. But once again, the units have to be converted so that they're all the same, and foot-pounds can be easily converted into joules. Fluid energy is usually measured in joules. And if the output energy is thermal, it's usually measured in BTUs or calories, which can also be converted to joules. In any case, measuring the efficiency of a device determines how much energy the device consumes and how much is being wasted. For example, a light bulb converts electrical energy into light, but it also produces a lot of heat. A fluorescent tube does the same thing, but it's far more efficient because it turns less of the electrical energy into waste heat. Sometimes a device is inefficient but still useful, like the laser. Only about 1 to 25% of the electrical energy put into a laser comes out as the beam. But laser beams are able to cut steel and are so useful that their inefficiency is still worth it. Another important energy converter is the solar cell, which converts light into electricity. They're useful but expensive and inefficient, something which Keith Emery is trying to resolve.
The first thing that I do to measure the efficiency of a solar cell is to set the intensity of my light source to be 100 milliwatts per centimeter squared. I need to use a reference cell which has been calibrated outdoors with respect to the standard solar spectrum. So I put the reference cell in, adjust the intensity of the solar simulator to be 100 milliwatts per centimeter squared, and then place the cell that I am going to test inside of our test station. Another thing which I must do in order to make efficiency measurements is make contact to the solar cell. In our laboratory, we rarely receive solar cells that have wires attached to them. So I must use probes to make contact. In addition, we have a vacuum plate which makes contact to the back of the solar cell. So now I am going to make contact with the solar cell, which I have done. And this test station over here verifies that I have made contact. In this case, I have 9/10 of an ohm across my voltage and current contacts to the top of the cell, and 1.1 ohms between my voltage and current contacts to the back of the cell. The automated measurement system has now evaluated a solar cell, and I will plot the cell up. The curve here represents a good solar cell, while this curve represents a bad solar cell. The points marked here are the maximum power points. This axis is current, and this axis is voltage, and these points mark the short circuit current points. The future of solar cells is more efficiency at lower cost.
Solar cells, or photovoltaic devices, are appearing in technology where electricity is needed in a small space, like calculators, which can use them instead of batteries. The camera that recorded this program also converts light into an electrical signal that was stored on your videotape. In the continuing effort to improve this technology, a new camera has been developed that uses a converter called a charged couple device. Ed Rosenthal explains.
We have an example here of an older technology type camera versus a modern day type technology camera. As you can see, the older type technology is a lot bigger versus what we have, the newer type, much smaller and much more reliable, in 100% solid state. How we make it 100% solid state is converting light energy into electrical energy. By doing this is a new type of device called the CCD. The CCD is example of a charge couple device system. Here we have a diagram of what these two devices do. Takes the image through a lens and it's converted into this tube. The photosensitive device is on the front of the tube, goes through the tube, and it's outputted at the end. This second diagram is taking the same image through a lens into a charge couple device. The image is shown on the front of the photocells and outputted towards the back. There's over 200,000 small CCD or photoelectric devices that's in this one little square. Now I'm going to show you how these two cameras operate differently. Here we have a special picture that's split in two different parts. On the left-hand side, you see the modern technology type camera. On the right-hand side, you'll see the older type technology. In this particular application, you do not see any major difference in the picture composition. As I pan over here to the candle, you'll see on the left-hand side, there's no comet-tailing, no type of burn-in, and no lag. On the right-hand side, you can see the major disadvantages of the older technology.
Optical converters are the prime source of energy for most spacecraft. Once the electricity is generated, electrical converters like motors, heaters, and transmitters convert the electrical energy into various other forms of energy. Since space is limited and costs are usually high, it's critically important that these and all energy conversions take place as efficiently as possible.